Welcome to Physics to Pi. Today I am going to share you why sky is blue. Well, the answer is really complicated because you have to know a lot of physics and the equations which deals with these explanations. Now you can see the sky is blue just because of three main reasons. So the first reason is the composition of the sunlight spectrum, and I will discuss it later. But the second reason is the atmosphere, the composition of our own atmosphere. And the third one is the human eye, the capability of the human eye. And that's the third reason. So today I'm going to share you the three reasons. Alright, so you can see the atmosphere, the human eye is the last thing. But the problem, the sunlight. The sunlight is the source of every light coming from the space to the earth, and then voila, in the daylight whatever you are seeing is nothing but the sunlight. So sunlight is, if you just draw some kind of sunlight spectrum over time, then you will get these things. Alright, so you can see the sunlight spectrum in space is as a function of frequency, where you can see the red light from behind the red light, it's the infrared, and above the after the blue, the violet, it's becoming more frequency, the frequency is increasing, and the more you are going to the infinity, it will become X-ray, gamma ray, and so on. So here is the questions that if you look at the spectrum, you can see the maximum energy from the sunlight we are receiving is in the region of the infrared, the red light, then yellow, then the graph is slightly decreasing. Alright, so here is the Planck spectrum of the sunlight, where you can see the maximum intensity is somewhere different. So visible light is somehow green to yellow to red shifted. Okay, so it's important to know before we jump into the main point. So you can see the ultraviolet ray is kind of steepest, but not too much at the peak. Now look at the atmosphere. If you look at the atmosphere, you can see there is a lot of air molecules in our atmosphere. Dust and water vapor, we have to include that one also. So you can see that air molecules, if you consider the air molecules of the total atmosphere, then obviously we will get the nitrogen as 78%, oxygen as 21%, and argon, carbon dioxide, and water vapor and whatever, it's kind of 1%. So it's kind of weird that everything in air molecules is kind of same size of the wavelength if we just convert into the particle size. Alright, so they can interact. So coming to the main point, it's scattering. So that we can't see the space in the daylight just because we have atmosphere. This is the equations Rayleigh wrote it. So it's, if you look at very closely, it depends on pi to the power 4 r square, where r is the distance between scatterer and the observer, and then theta depends on the which angle the scattering happening. So in simple words, it's I equals to 1 by lambda to the power 4. So if lambda is decreasing, I, which is scattered light, will be increasing. If lambda is increasing, scattered light will be decreasing. Alright, so here is the thing. So if you can see, this is the red to violet and their the wavelength. So the more frequency there is, the less wavelength there is. So red light has the less frequency and the biggest wavelength, and the violet is the vice versa, the opposite of the red. So obviously red light has the maximum lambda, so obviously I will be minimum here. So the scattered red light will be minimum here, while the violet, which you can see, this is the frequency of the violet is kind of bigger than the red, then obviously the intensity of the scattered light will increasing for the violet and the indigo, the blue. So if you look at the graph here, you can see the scattering also depends on the wavelength. You just graph it, plot it with some the percentage scattering of the direct sunlight, then you can see about 20 to 25% just blue light is getting scattered, and red light is not getting scattered too much. Alright, so here is another plot. You can see violet light is too much scattered in the violet, and the indigo blue is scattered too much in the atmosphere. But the problem, we can't see the ultraviolet and the violet light in the sky just because our eyes can't see those colors. Why cloud is white? You can see the dust and water vapor is the answer. So if you look at the white sky, you know the dust and water vapor which absorbs the light, but water vapor here, the white sky means water vapor is huge but dust is very less, and that's why it's so water vapor, what happens, water vapor nothing absorbs, rather it scatters every light in every directions. So whatever you are seeing, it's simply white. Alright, but if you see this black, the cumulonimbus, the cloud, then obviously there is more dust. So dust absorbs the sunlight, that's why it's black. And the last part is human eye. Obviously human eye is more sensible to the blue, the green part and the red part. If you look at the very closely, you can see our eyes is too much green light just because we require more stress, more energy to look at the red to the ultraviolet, while green, if you are looking at the green things like trees, the jungles, then obviously the stress is very low, that's why your eyes is very comfortable at the green. So the blue part, that's why we can see the blue part which is kind of visible to the human eye, also to the cameras nowadays. So ever on this series, so I will continue this series. I know this is my first video, so I need a lot of improvement over time. So if you have any suggestions, if you have any kind of feedback, then you can comment below. And quality. Thank you for watching.